All right, I will welcome everyone again on the multi-network community sync. Today is January 31st, and we have Michael today, Zappa, talking about the KNI. Take it away, Michael.
Sorry, I had a mute. We actually have a hand raised already. If someone
Oh, there
wants
was
to.
some.
Yeah, that's me, the problem child. So this is Fatih from Red Hat. So Doug, this question mainly to you, that we have this conversation before, mainly around the high performance computing requirements mapping into multi-networking inside the Kubernetes, where we see a lot of use with RDMA use cases and so on and so forth for achieving high throughput multiple network interfaces. Did we ever consider those requirements in this design so far?
You're asking for multi-network or for KNI?
Multi-network.
Yes, we did.
Is it documented somewhere? You can share me the
Yeah,
document.
it's if you go there, there is a the first ongoing document on the top of the link I sent. There is
Yeah.
multi-networking cap, and that one uh, doesn't. Sorry, step back. There is a PR second line on the doc. So there is a PR, ongoing PR, which has the initial use cases and the requirements for this whole endeavor, and just I can link it as well in here.
No, I'm looking at the GitHub repo, which is a 3700 pull.
Yeah, exactly that guy.
Okay. I'll look at it there. Thank you.
Yeah, that should have all those. Leave comments if something doesn't work for you, and we can work on that doc if anything. All right.
All right, we good to go. All right, cool, sweet. And we got the. Everybody can hear me okay,
Yes.
and let me know if the text is too small. We can always enhance. This is pretty big, right? We got it. Everybody got 2010 vision.
Go ahead.
Cool.
I think
Right on.
someone's complained.
Yeah. So I think the idea here is just to kind of go through some of like the high level, pieces of K&I and how they could intersect with multi-network. And to start off, I'll give kind of my approach is that we currently do have something called the CRY API, which is, broken down into two services, runtime and image service. Image service is pretty much not related for here, but the runtime service is what calls run pod sandbox, pod sandbox status, create containers, start containers, and more. And instead of creating a new network service in there, in that CRY API, I just decided to make my own KNI API, which just included attach and detach. And I started very simply with that as more of an iterative approach. And the big piece of the puzzle for, the attached network is that I didn't make use of pod network or like a slice of pod networks to be passed down. It was more or less very generic, which I think would be, something that we would intersect with, the multi-network effort is, would attached network be responsible for one or many interfaces or attaching networks, for lack of better words. And I actually didn't even, I wanted to take more of an opinionated approach. I was like, well, attached network could attach one or many, but we went from there. So I think I want to talk about the high level moving parts of the kubelet code base because I think this is where a lot of people start to get tripped up. So I think what I'll do is I'll do like the pod creation, the network attach. We can do the reverse, like where we delete the pod. So we're creating the pod, delete the pod, and then we can dive down into, say, like the container runtime in the roles and responsibilities of that, like where things currently work out. And then we can go to, say, just the sample network runtime. And then we can go to, say, like just take a quick look at the KNI API, and you can see where, the simplistic approach that I took just to see if this was possible. Does that sound like a reasonable approach? I think a lot of people don't understand the high level moving parts of how like the kubelet works down to the container runtime to the network.
That sounds great. Go ahead, Michael. Yeah, I think that's
Cool.
awesome. So let's maybe go step by step with the creation of the pod with KNI. Is that what we want to do? I think that would be okay. Go ahead.
And I can break it down to like, I'll point out where I made the changes and kind of high level what's going on. So what we're currently staring at right now is pretty much the meat and potatoes of, oh, and I meant to mention network readiness, but we'll get to that if we have enough time. So SyncPod is like the meat and potatoes of the kubelets pod creation process. Effectively at this point, kube scheduler has binded the pod to this node. So effectively, this pod kubelet knows that it needs to go do something. Effectively say, hey, well, the pod should be running. I'm gonna go make it so. And effectively, we can go up through the code, but the main pieces of the puzzle here start to begin right here. And here's where DRA kind of starts. So line 1181 is actually where the gRPC call to the CRY API network service happens. And it says create pod sandbox, but this is actually where the run pod sandbox gRPC request starts. And in the current, without, multi-networks, KNI and more, this is what, creates the network namespace. This is what executes the CNI and more. And it returns just a pod ID. It's very simplistic in that manner. It doesn't return, anything else. There's another RPC call that happens. So I'm going to just gloss over this really quick, that we do consolidate our code to an attached network function. And I'm going to go into that for a second, but I want to state the order of operations is that we run pod sandbox, then we attach the network, and then this is actually where all the various containers start to get started. Your, ephemeral containers, your init containers, and your regular containers. So we can actually show that, the attached network must be completed. That should be our guarantee that, we have started the container with an actual working network. So let me collapse this, and I don't know why that's open. Bache, question.
So, and I assume we care only up to the attach, right? Point in here. The rest, basically, you didn't change that. So basically, create sandbox and then attach. This is where we care, and the rest is just the same.
Yes, we don't change anything with the containers like lifecycle.
Yeah, right. That's
because and that's where a lot of people were thinking that the order of operations was different. People were assuming that we were doing run pod sandbox, create and start containers, then attaching the network, which doesn't make any sense.
Right.
Your containers would just be in a crash loop. So the big meat and potatoes here is that we consolidated a lot of the networking code into this attached network function. And the role of this, actually, a lot of people are very kind of curious about why pod sandbox status actually exists. And in the current form, you actually use this to get the pod IP addresses back. It comes back as pod IP and then additional IP addresses. So if this request were to fail, then the pod actually fails. So we actually leverage this to get some information back from the container runtime. Specifically, we get the network namespace, which we actually need because right now it'd be completely decoupled. And there's some talks to actually modify the run pod sandbox to pass back the network namespace for us. So effectively at this point, we're calling down into, we're doing the attached network gRPC request to the network runtime, which is responsible for setting up the network. And you can actually tell that there's nothing pod network related here, which, if we were to take a second stab at it, I'm sure we would leverage, the pod network resources that we already talked about, plus the pod information, the metadata, the labels, annotations, and a few other things. Go for it.
Other way around. Yeah. So, but how? So right now you got everything from the pod, right? And what is the expectation later on? Where is the linkage of which pod network or whatever for that particular pod? Is it still coming from the pod?
So that's where I was just stating that if we were probably to take a second stab at this, it would leverage the pod network resource right here. It would be probably, if I were just to throw something on the wall, like, we need information about the pod, but we also need information about the pod networks. And I'll use networks as, plural.
I understand.
I just didn't do it because it actually was a lot more work. And I wanted just to prove the theory about, I can separate the network setup and teardown from the container runtime. But
then I see you are not passing any pod info. The pod itself is not passed here. Is that by design or eventually, or it is?
Yeah. So the pod information, and are you specifically, so the labels and annotations of the pod are getting passed in right now through this call. It's actually coming back from the pod sandbox status, but you can actually grab it off the pod type itself.
So why I am drilling this. Mine initial kind of picture of this whole thing was the kubelet side bases everything off of pod spec. And basically, as soon as I change pod spec, I'm done. I don't have to do any other API changes. That was kind of till before K9. That was my kind of idea on this one. I assume this will still be the case, right?
Yeah, this is 100%. That's why I kept that. That's why I said earlier is that's where we'll have to make these changes. I just didn't want to add.
No, I understood. I understand that you didn't. I see what you say. Yeah, okay.
But it would be the pod. We would be passing in the v1.pod type.
Yeah.
So from there on, actually, you'll actually notice that I actually make use of the response type, specifically because I wanted to keep the changes to an absolute minimum. In the current, we actually make a call back to the container runtime to get the IP addresses, and there's actually no reason to actually add this additional query pod network. This was just to maintain the existing pattern. However, we can reduce, the actual additional call. So in this query pod network RPC, effectively you pass in the sandbox ID, you get the IP addresses back, and then we pass it down to the network type off of pod sandbox status. And this was just to reduce the changes, because once you start making small little changes, the kubelet actually does start to fall apart rather quickly. There's a lot of little landmines in the kubelet. If the pod IP address does not come back, that actually causes the pod to be constantly rescheduled. Go for it, Maciej.
So I have it, but I had a question. Sorry. So in here, the response status. This is the pod status object, right? Is that true, or that's something else?
Pod sandbox status.
Oh, sandbox. So this is not the pod object status.
Nope. So and
so that being later on in the later code, I assume this is being then translated into pod status in some way.
Yes, and actually, so the status type, actually, there's a piece of code all the way back up in here. And I kind of skipped over that. And this is a great thing to call out right here. So if you start to trace your code to the compute pod actions, this is effectively says, hey, has something changed or something, effectively wrong? Do I need to tear this pod down or not? And it actually was coupled. The actual Cry API code is coupled all throughout the code base. So you actually see that it checks if the network type off a pod sandbox status is nil, and then also does it have an IP address? So it actually will come back and to bite you. And so to reduce the changes for the POC,
Right.
I simply didn't make those changes. But yeah, it's the naming convention gets a little trippy. In fact, it's very confusing in some cases. Does that answer your question, Mache?
Yeah, perfect. Yeah.
Cool. I'm gonna go to, all right. So that wraps up the creation. So you can kind of see the order of operations, and there was various ways to make this improve this where it actually makes use of a type versus my very generic approach that I took. So the next piece of the puzzle, and this is where actually I thought we were going to have the most issues, was the teardown. Because for some, and you can think about it, because a lot of concerns were, well, what if you stop, detach the network and the pods or the containers specifically are still running? Luckily, that's actually not the case in the kubelet code base. So the order of operations here on line specifically, 1383, is when kill pod is finally, called, we're actually stopping the containers at this point. The containers are now stopped. And now, the existing order of operations would be to actually call stop pod sandbox. And in this case, we inject another step because we removed the CNI delete from the container runtime. We didn't remove it. We feature flagged it. And we detach the network. And obviously, if the detachment fails, we want to have the same behavior as a CNI delete. Because the last thing you want to do is just delete the pod and leave a bunch of stuff lingering about. Not the greatest approach. So this actually says, hey, if detached network fails, reschedule that, and it'll keep trying until it's actually successful. And then we finally call the stop pod sandbox, which goes down to the container runtime and says, hey, go ahead and delete my network namespace. That's actually the more simpler one. It actually thought it was going to be the hardest one, but the existing RPC kind of really worked together. And some of the backstory here for a little bit of a history lesson is that originally there was no there was no start and create containers. It was all done in run pod sandbox until it was decoupled. And whoever, designed it back in the day, 6 years ago or something, actually made it quite easy to break this apart. So I'm going to go down to the Cry plugin of Containerd, which we've already kind of high level talked about run pod sandbox, but I figured I give more people a little bit of a visual here, simply because no one ever tends to look at this code. Did anybody have any questions around create and delete of the pods? And if not, I will kind of go down to the run pod sandbox just to give a quick high level, and then we can go to the sandbox status, and then we can go to specifically the status where we get readiness. If not, no questions. Cool. All right, the run pod sandbox is obviously the Cry plugin of Containerd. There's nothing terribly exciting here other than, where is it? Is this the right one? Yes. We're obviously creating the network namespace, which is, a prerequisite for the CNI. And in the current, we would actually be calling, setup pod network. And because we wanted to move, oh, come on. There we go. Because we wanted to remove the CNI execution, allow the network runtime to do this, we actually just add a config flag. And I think the maintainers of Containerd expressed more interest in the kubelet passing down information to the container runtime to disable the CNI execution. So as simple as that. But if we weren't going to do that, we obviously come down here and execute the CNI. In Containerd, there's a package called GoCNI, which wraps the libCNI, and we go from there, which obviously in this case will be executing the CNI add. And one other thing to note is that between line 488 and 492, there's actually kind of an unspoken rule about ETH0 needing to exist and that it needs to return an IP address. So this is where things kind of get a little bit funny because, no one's ever actually said you need an ETH0, but like what stops someone from using net0, net1, whatever your heart desires for interface names. So something to keep in mind, from like if you were to create do like attached network, and if it doesn't come back with IP addresses or ETH0, these are kind of those things that Kenny and I help to kind of define. So we actually always know that there's an ETH0 present or whatever name. Does anybody have any questions? Oh, yeah.
Yeah, I do. So basically you are preserving these requirements in KNI as well, that you have to return ETH0?
I don't have any thought around that. I think part of like a community sync, we probably should start. What?
I'm sorry. Just seems early to worry about that just yet.
Fair, Shane. Okay.
Yeah. Well, Machi, what are your thoughts?
Definitely default to ETH0, but if we were to have ability to, it shouldn't be enforced, right? Unless there is, because who, except the standardized like awareness of the community that there is always ETH0, is there any code hard coded to ETH0? If not, then we shouldn't enforce it, right? And we just, default to ETH0, but I should be able to change it in the future so that we don't have to, if you're already re-implementing the whole thing, that's just my gist. This is a small thing, won't require big change in the future, but unless there is some hard code, up the code in kubelet that says, oh, I need to have ETH0 always, and I will break you if I don't.
Yeah, and in the realm of multiple networks, why don't we just say like multiple interfaces just to keep things simple, is that there needs to be coordination there, because what stops you from saying having network A, B, and C, and they all want to say create a new interface called ETH0. So we obviously
no,
need
so
to
that
keep
part,
that
so Michael, that part would be handled then by the pod spec. That where we were saying that we would push it. We know whether we would get it there, but in pod spec, you would, if you call out the names, you call them out there. And if anything, if there is an overlap, the pod validation will fail, saying, oh, you have the same name for all your interfaces. Fail, and you won't be able to even apply such pod. That was the idea, because it has to be centralized exactly for the reason that you're calling out.
Yeah, so you and I are saying the same exact thing, that we need some level of coordination here, because it wouldn't make any sense. And that's actually a problem that we experience today. Not necessarily interfaces, but you can also say like it's all, not to throw shade at anybody's like current implementations, but the amount of times I've said that your second network has deleted your default route or all of your routes. That's why you don't have connectivity, is because we lack the coordination between, these other, attachments per se. So that was kind of like I unfortunately had a document with all of my kind of like experimentation notes for KNI. Unfortunately, it was on my laptop,
Oh.
not on Google Docs, which, I'll fault myself for that. I owe everybody else a beer for that one. But yeah, so those are like just the cool little call outs that we start to see with like, hey, what happened when KNI called a whole list of, CNI configurations? You're like, oh, well, there's actually a funny bug in Go CNI that no one's ever probably come across, where it just tries to reuse ETH0 constantly. I had to fix that. But that is like a great call out, is that, these are the things that we'll have to think about. And we already have in a lot of cases. Like Vache, you hit the nail on the head. But is there any more questions? I was going to go to pod sandbox status, and I know you had some questions kind of earlier, and probably should have started the other way around. However, I started from the top down. So, all right, no questions. So, like I said earlier, pod sandbox status is responsible for returning IP and additional IP addresses back, which, you can start to see that, I don't think IPv6 or like, dual stack or more was ever really kind of initially thought when, the Cry API was being born here. And you can kind of tell where people started just adding fields wherever needed. So it's probably something to eventually address. But the main point here is that this is what is responsible for returning IP addresses. So in the current model, we have this decoupled approach where run pod sandbox kind of does everything, but it only returns the pod sandbox ID. And, I kind of was like wondering why that was. I was like, is this DHCP delay or more simplicity? But, not too many people around that can actually articulate the whys there. And the big change is just to support, the KNI was between line 89 and 99. Just to return to network namespace. And I think there's more desire now to support Kata with a different create call that actually creates the network namespace and more. And you'll actually see line 96 and 98 because that's to support Cilium. They actually make use of the C group path for reasons I don't know. Identify the pod or something. Any questions there? This is really, meant to return, various information, the metadata on the pod and more, so your labels, annotations, runtime handler, nothing too exciting. All right, moving on. And I know for multi-network, this is an area of interest. So I'll just throw that flag up here. The flare has been shot. Is obviously we disable the CNI here because currently today, the kubelet has a function called uptime runtime something or runtime something. I don't remember the name of the function, but it's what's responsible for calling the status cry function to say, hey, is my container runtime ready? Yes, it's always hard coded to true. And then the next big piece of the puzzle that's more relevant for us is, a runtime condition. And in the current form, you'll see line 53, the status function. That effectively says, do you have a CNI network configuration? Yes or no? Internally, it says that the minimum count is 2. So you have your default, and internally you have this loopback plugin present that's setting loopback to up. That's a different conversation, but you can actually see that right now the container runtime is responsible for saying like, yeah, my network is ready, aka I have a CNI network configuration present, and or I don't, and then it sets it to false. That sets the node, if you were to do your kubectl get nodes, it'll actually say not ready, which poses an actual problem. Like the condition, the fields on the runtime condition, that's annoying me, are pretty simplistic. We got status, which is a Boolean. Reason, it's not ready, it's a string, and then we have a message field. And I don't know, Mache, like if you're looking at this, you're kind of like, I wonder like how this lines up with like, hey, if I have network A, B, and C, what's the deal? Because I feel like it's missing some pieces here for context.
So not exactly, to be honest with you, because node, I would, maybe we can expand it later on, but initially I was thinking this should still present stuff only for the default network, the default network. The other networks, A, can be node selective, so don't have to be available on all the nodes. And B, they should not block scheduling of a normal pod because network A, which is additional network, is not ready yet. Additional networks should not make the whole node unready. So I would assume the way it is right now, it's good because the only thing this should make sure it only checks the default network's readiness. And that's it, basically. And keep in mind, pod network object will have a readiness stuff in it. So depending on who's gonna check what, it can be the case where implementation is going to update that object, and instead of you checking whether there is, because right now you just check whether there is a CNI file, which is very basic, or no, you do the status. I think Antonio did some changes so that you can check a status of the call, right, as well. I think there was some recent change on that one, so you don't blindly just check the file existence, but as well you can call to the CNI itself and see what the status is report, right? So you can be more what I want to say smart about this, not just file path check. So that was recent change, I think, if I'm not mistaken. So that's good as well, but this is just on a node and the CNI itself readiness. And what we can look at it here is how that status check, because right now you're calling CNI as a file path, right? And I'm thinking like Cilium, for example. In Cilium, we don't use the paths at all. Cilium, you will call to the agent through the status, and that agent will tell you, oh, I am not ready yet. I am still spinning up whatever, though I'm up, but I am spinning up my compiling stuff, what's not, right? So CRI will call to the CNI and get the status, and he will tell you, oh, you got me, but I'm not ready yet. And it will tell you, no, I'm not ready, and it'll still keep the node down. Further on, I think that was still purposefully added to that so that you can dynamically back and forth the status, because today, if you set it true, you cannot revert it. You cannot, if you delete the CNI file path today, the node will not go down. It will go down only if you reboot the node. You will come back up. Oh, the file is not there. I will make the network not ready, right? Reason. But with the status check to the CNI directly, we are able to go back and forth, right? Saying the node, oh, CNI went down. I will make the node ready, not ready, right? But that's, I think, there is a mix of two things, right? Having the agent that handles your networking ready or not, and then what that agent reports, or for what that agent reports, right? If let's say my Cilium agent is going to handle all the multi-networking for me, right? And then it's up to me and my implementation on how I'm reporting, whether I report only for the default network or for the whole thing, right? So I think in this matter, this cannot report definitely all the networks, at least in my opinion. I will let other folks chip in, but in my opinion, they should not report all the networks and only the default network, right? Maybe it should report two things. A, the general availability of your CNI, and B, the default network, right?
Yeah, so one thing to call out there is that there's actually a code called it's the CNI Syncer, and it's under the server directory that is a file watch on Etsy CNI Net D. And that actually watches for file network configuration changes in there. So what would
Oh, so it
happen is,
will.
yeah, and if you were to delete anything in there, and there used to be a bug if you delete the whole directory, it would just stop.
Mm.
But it watches that directory and it'll set status in here, and I'll decouple status from CNI verb status. These are two different status. They're just named the same. So it'll actually set the
Oh.
node not ready. And because the kubelet on a 5-second interval, part of this uptime, uh, something runtime up, I forget the function name, but it's in the kubelet.go file. If someone wants to look it up really quick, it's a 5-second interval and it's constantly calling status. So it'll set the node not ready if that file were to go away, which, becomes a problem for a few things, because now the CNI status verb becomes, useless because it doesn't know what plugin it's actually calling anymore. So, and then you hit the nail on the head, is that this isn't really aware of multiple networks. And I think the other part here is that networks aren't just like, simple Boolean. They can be present or not. However, there's a big problem with the CNI add right now that exists, that, what happens when your IPAM runs out of IP addresses. So what does happen is that, the pods can't come up. They're in kind of a persistent, loop saying, I need an IP address, CNI add fails, and goes from there. So network readiness is more than just like, is it present on the node and more. So we got to look at it from that perspective, that, what happens if, you have primary or default, and we're using default network, right? Is that the
Right.
vernacular?
Yeah.
That comes up, cool, which is great because we want to be backwards compatible. The last thing we want to do is, break some of that behavior. But then it's like, yeah, if the network comes up for network A or VNet, VPC, whatever cloud noun you want to inject there, that we want to be able to provide that status. And part of KNI, you have something to say. Do you mind if I finish
Yeah,
the thought?
it's the thing here with the status. Keep in mind that we are adding that condition to the pod network, where implementation can directly report whether the network is ready or not globally, right? Of course, there is a per node status readiness, and this is maybe where you or KNI would come into play. But there is a global status for the object itself, which implementation handles, and it will be respected, and at least in the design, it will be respected by the scheduler, and it will not schedule a pod. It will say, oh, this pod uses network A is not ready, so I will back off. It will be in pending state because network A is not ready. So there is one level of that readiness defined, and then there is the per node level, because there are always two, right? You can have the object ready. Let's say you configure your switches, and then you set up your network A to be ready fully, but then your per node configuration has to update as well. And this is on a per node level, and this is where maybe you can come in. So this is other thing that, yeah, it's there is always it's not because the pod network object is centralized, right? And you cannot centralize unless your implementation does that. That's a case as well, where I will report my network A ready only when all my nodes get ready. It's not optimal, because then you wait for the last node, and if the last node hangs, your whole thing just is dead. So it's better when you have per node readiness plus that centralized object, right? And your implementation can juggle on what and to do where, right? That's the aspect of the whole thing. And I wonder where the KNI would come here, right? Because yeah,
Well,
that's something that would have to, because that's exactly, we maybe we can ride on the KNI here to have that per node readiness for a network, right?
Yeah, so let's break that down really quick, because that was one of the big things for the KNI, is that one, we didn't want to be involved with the scheduler. That wasn't part of our scope. However, what was in scope was providing down to the specific node, because the network runtime would be running on every node, is that it exposes an RPC to say, hey, what networks are available on your node? And I'm saying networks, not network,
Yeah.
because we needed to keep that into account. So the idea here between like what networks are available on the node is more or less, hey, if DRA or the scheduler wants to know what's available, great, we can provide that. And even better is that network is not just true or false. I like really want to see that like the last thing we're going to do is set a network to not ready because it has no more IP addresses and trigger eviction. That's a problem. So the that's where I was hitting, that the status is not simply true or false. It's more than that, and it needs an additional step.
The other things would be the reason, right, Michael? I think that's the status would still could be simple, true, false, and only the reason for that, right? And that will give you the whole information you need, right? Want it? Or are you saying, and then based on those reasons, since those are programmatic, I assume you could take actions, right? If you want to. If you don't, then just give that information to the user and they have to do about it, something about it. But if not, then if your automation your implementation has to do something about it, it can be hooked on those reasons as well, right?
Yeah, and so that's where, I'm trying to dig up the code for what I've been mentioning, that like uptime function, and just give me time. But effectively, it looks at that status. So if that goes to false, that node is now in the current, and I'm talking about the current today, and that's the big problem, is that
so this is where we would have to tweak the kubelet side because that status will be tied to a specific network, right? And a name of a network, right? And then on the kubelet side, we will have to say, oh, we have to change two things. Loop over all of because there can be networks, plural. That's one aspect. And the other aspect, you only have to watch the default one. If the default one says status false, set the node false. That's a fair point, yeah. And basically this is what we could do initially. And then, because where would you report? Because that's the problem right now, right? And I don't want to go there with multi-networking yet, because that's going to be even bigger change. Where do I report the statuses of the other networks?
100%. And that question was one of the big drivers to, say, decoupling a lot of the multi-network and bringing it into KNI. Like that was part of like, how do I report multiple networks? What is available, and breaking it down to what does readiness mean? I need to know that, the scheduler eventually need to know is like, hey, I'm out of IP addresses. And what I don't want to do is set the node to not ready, which will trigger an eviction. So we need to add a status to say, hey, no more. Like, no more. You can't.
Yeah.
The scheduler eventually will need to be aware. However, that's where we didn't want to jump in. We wanted to provide the RPCs, that multi-network, and the scheduler or DRA could eventually use as a means to reduce the scope and make the the target for multi-network very specific here. And that kind of, because like there was a lot of moving parts here. This is like right now, network status, like while I can return multiple networks today in the POC, we don't handle that other than the first element in the slice, simply because it's not set up that way. And that's the big, I mean, like we can return it right now, to the point. I think what we really need to do is kind of start coming in here and thinking about that. And that's where that pod network resource, like, as today, you could do everything, but you can't do that. And that is where I think the KNI really came in to start using that pod network resource, is that we need something, one, obviously, to say like what pod networks are attached to this pod, but also to say like we need an actual type here to specify these, various conditions that can happen. It's like, I'm out of IP addresses. I'm not out of IP addresses. Come over here. Schedule and more. But we did not want to touch the scheduler. So I think there's a piece of like network availability, network readiness, and then network metrics that KNI really wanted to offer multi-network and whoever else in this ecosystem. And not to be stuck into like a single network. I think that would be, we would have the same thing today in a different location. That's not very cool, but we wanted to decouple some of the scope here. And this is like, the bigger magic that we'll obviously need to think about, of like, if the primary goes down, that's bad. Like, and we have to break it down to like, it goes down, like, did it run out of IP addresses and they're not scheduling anything anymore, so that's great. But the approach of just evicting everything is not a great approach, especially if you just ran out of IP addresses and more. So
that can be intelligent in terms of exactly what you said, conditions. And since this is in Kubernetes, right? This is kubelet. This guy can mess around. Can it? No, it cannot. Okay. It could not mess around with the pod network object because kubelet is a distributed element. So we should not allow distributed elements manipulate one object. So yeah, that's something that we didn't address yet, because that would mean something. There was so I had recently, this Monday, I had a meeting with someone in my company about what they're looking at DRA. So I had some insight what they're planning on do and slightly update DRA so it's being less complex. And I think they called something, they are thinking of introducing object called node resource or something like that. A new object, built-in object, something to not expand node because it's already large. And this node resource could then hold, because it will be per node, it then could additionally hold what networks it has available and what conditions of the networks are, all that, right? And I would just wait for that, if anything. I would assume KNI should definitely from the get-go report multiple, plural things, and then just in kubelet hack it so it just do the one, the default, right? When we introduce the multi-networking, then it will just do the default one and only report on that one. But then in the future, what we could do is when we add that, we would have that node resource thing object, then this loop could update that guy, and then scheduler could be dependent, and scheduler can look at that object and see what networks do I have available on that particular node. And that will be out of your scope because that will be then indirect, right, for your point of view.
So not exactly. And so there was a talk yesterday or past couple of days with Kata, and they actually expressed an interest and actually threw an idea out. And if you remember, that RunPod Sandbox was responsible for creating the network namespace. And the actual CNI execution is where it is today, because the pause container start actually triggers additional network setup for Kata. So they actually said, why not put another RPC call down to the network runtime that actually also creates the network that creates the network namespace. So we'd actually be in complete control of networking. But it also was this also start thinking about is like, well, pod network resource could also be driving, hey, should I be, letting the network runtime aware that, I have network A, B, and C or more. So in that case, the network runtime has knowledge of the pod networks, but also this starts to give the ability that the kubelet is also aware of the network. Well, the node is aware of it. So we can actually use that as a means. And this isn't to steal DRA's thunder because we're already talking with DRA as well as a means to say, hey, well, if we can tell you what networks are available on this node, can you tell the scheduler that, be the glue or the medium to say don't schedule networks here?
So this is where that pod resource would be that median, that indirect element that will do that for you, because though you will be still used KNI, but then how do I expose that to the user or to automation? Otherwise,
Yeah.
I would have to have some hack to go to every node and run your API. I don't want to do that. Kubelet should do that, right? So Kubelet will call you with the grabbing the statuses every 5 seconds, and then Kubelet will be the one that will report it somewhere, and that somewhere is where DRA is coming up with this resource, built-in resource. And basically that will be it, right? On top, they will add some other thing, because this is where we would add the networking stuff, right, as well. And
So
that
does
will
that
be it.
resource reference the pod network resource that you envisioned, or do we deprecate that now? Because now you're kind of,
No, pod network has to still be there, right? Because pod network defines what is the network for the implementer, and the implementer has a means to define what is the network, right? And basically this is completely independent. For you, for the scheduler, they just need the handle, and the handle is the name of the pod network, and this is the only thing that you care, right? What is the name? And basically I move around the name all around, right? So the node resource will care about whether the name is available or not on that specific node. You will care about what networks do I need to create. So this is then I need to pass those pod networks to the implementers. And then when I go back, when I get the statuses, exactly, and the same thing, right? I only care about the handles, the name. This is what you care about. So we still need the object, because you should not care, nor DRA should not care about how the network is defined, whether it's L2, whether it's SRLV or what's not. That's completely out of your scope. You care about the handle, and this is the only thing you should care, and the DRA should care, and all those, right? That's the point. So the pod network definitely has to still be there, because you care about the handle. What the handle means is the implementer's interest.
Yeah, and we're saying effectively the same thing. I was curious about the reference between, the DRA resource and pod network, that there is some sort of, referential logic between these.
Yeah, there has to be, right? There has to be a name pointing that, okay, this is the node resource object, and basically it has those resources. And I would envision this object will then even pull in the CPU and memory as well, and all the allocation and capacity from the node to that object, right? And because they want to do it more elaborate, not so simple as it is today. And then we can add in the networks, the DRA can add their own stuff over there, and that can be the one object per node that basically kubelet can update with all the status of the resources, right? So, but I think we are debating something that will be future. I think for KNI point of view, I would assume you do everything in plural, but then kubelet just adapt to kubelet to use the default network, or just the first one, right? Up and depending how you're gonna return. I would not want to push any hard coding on your side, on the other hand, stating that, okay, the first interface, I have to put my main default network as a index 0, right? I would not want you to push that, right? I would like that the default network naming should only be hard coded inside kubelet, not in KNI. K9, right? It should be more generic, unless you say differently, and you would want to have the default network hard coded. But I would say this should be kubelet side, right? The multi-networking with Kubernetes side that would have the default network, the special name hard coded, and it will look through the list of your statuses and look for the default one, right?
Oh yeah, definitely don't want to hard code things to index
Yeah, exactly.
0. And maybe like, because I think thinking about the world of backwards compatibility and not requiring everybody to slap, if they're not running multiple networks, last thing you want everybody to do is take the pod network and modify everybody's pod and say, hey, this is the default network, like whatever, Calico Cilium, and it's implicit that way. But like, I don't know if like I can't remember if pod network back for multi-network had like an explicit like is default flag that would be leveraged, and then all the other ones are not default because the
So yeah, we
logic
were
is determined.
there was just by name. We were calling this out just by then. The pod network will be named default, and there will be no special flag. I think we are at the time, Michael. Maybe before we kind of disperse, your KNI then will be that what you presented, right? We will have the attach, detach, and then with the ability of you providing Prular capabilities, right, to this whole thing.
So the what was presented today was just the POC, just to kind of kick the door down and find all of the landmines. And there's a community sync that has been established to talk about the design of the API. However, we are trying to really target initially the what and why, and then also I think, kind of figuring out how we can be the foundational element here. But I think it probably would, come down to, yeah, there's attached, detached, there's, ability to give network status, and this is all plural, obviously. And my simple design doesn't take into account, a slice of pod network resources just simply to keep things easy. However,
Yeah.
it probably should. So I think that's next week's kind of like, we'll do the how and why, and then, the API design will be very important. But I think, yeah, the high level structure probably maybe will be very similar. I think what will change obviously is more of the signature. Like, we're passing like the pod type or a slice of pod networks or, whatever happens. But yeah, those are the big things. And it does sound like we can help each other here considerably.
So on that note, what and other folks, if you can chip in, what from our current cap where we would want to introduce the object, will there be any changes that we'll desire, right, or need to do if you were to introduce KNI, right? If we were to pass the pod networks in a pod spec, right? Right now we were expecting that pod spec was passed to the CRI, and that was happening inside CRI by itself, and it was handled over there. With this, you are exposing some of it in kubelets, so I assume we will have to make changes for that one as well. What is your, Michael, target date for this?
Target date for what?
For the KNI introduction.
Oh,
Like
well,
alpha.
I think, yeah, well, we're introduction, like announcement. Sorry. What do you mean?
No, when do you want to do alpha for this? What is your target date that you're thinking? Maybe, I don't know, just spitballing here. Is it like 120? Is it the 130, the April release, or the summer one? Or even next year?
Probably, I mean, that's probably too soon. I mean, the very fact that this probably could be updated and more, I mean, we could target it rather quick. It's getting consensus around the API design is the big piece. Do you have like a target date in mind?
So I don't think we have to be aligned, to be honest. I just want to make sure that, because depending on who goes in first, that person will have to slightly adapt, right, the kubelet side. we have the cap, we have the discussion, but basically, my wishful thinking is to have alpha of what I presented in April. That was wishful thinking of mine. With the current state, I'm not sure whether that's possible, but I will definitely try to drive it there. If not, then I will hopefully get the cap merged in, and then if not this release, then summer release, right? Of course, I am keeping it and not addressing KNI at this point. I will keep it because you're in flux as well currently. So I would not want to keep it kind of address KNI there. But definitely when your KNI is gonna get alpha, this is where we will just connect and do stuff so that it can be cooperative. The one thing for this would be whether we want to have your feature without multi-network and multi-network without KNI, right? Do we have to then support all those cases, or we say that multi-networking has to always work with KNI and vice versa? You want to have KNI, you always have to have multi-network enabled in your cluster. And that simplifies the whole thing, right? Because then you have to go with all those permutations when one is disabled. But then up to you. I would be all open to enforce KNI if multi-networking, if you enable multi-networking, but that's the question for you if you want to do that the same the other way around. And that's, I will leave that, think about that, whether you want to do this. So that's kind of where I'm thinking about this.
Yeah, well, I would just say that there's already clear intersections here.
Yeah.
KNI certainly can help multi-network, and like I don't see a point to starting off with like, a single network, and then because once you go down to the network runtime, whatever you even put in that RPC, I can say I can create 50. So it probably just makes it's easier just to take into account from the get-go that it's some sort of slice. And if you're proposing passing, say, the pod type, we already get said
exactly.
The pod networks or reverse, like with label selectors without or annotations. It doesn't matter at that point. But I think the pod network resource or whatever that resource is, I think we should be in alignment there, because if I say, it's a square peg and you're like, no, it's a triangle.
So I think, so having that said, my cap doesn't propose any changes to the kubelet side, right? We just changed the pod spec, and this is where our buck stops, at least the current design. So this is good for both of us, because then I can be the first one going in, and then when your changes come in, they directly require multi-networking, and the pod already has the multi-networking stuff in, and you can then do plural from the get-go, right? So I think this is what good, because anything we would add for multi-networking, there is no changes that we would do in the kubelet side. There is no proposal to do any of that there. There are only suggestions on how the CRI could change, right? So this is the good part, right? Then you're independent, and basically the only thing that you would have to do is we would have to work out the or you would, in your design, you would have to address that, okay, my pod now has the pod networks, and how do I react on that?
Oh yeah, it's like that all sounds reasonable, because I think your model already has some form of like running process controller or more. And then like the KNI world is that you could obviously just implement the attach and detach and more, and you have the controller, and it all seems to line up rather well. In my head, I can show you. I don't know if you've gone through the presentation.
Not yet. I need to do that, and your doc as well, the one you shared before. So I need to do that as well.
Yeah, and that I'm updating the doc over the next few days. I thought I would get it done today. Because part of one of the slides for the network runtime, specifically kind of like probably, I think it's slide 6, probably will be very intriguing, since that's effective. I think your idea was that you have a controller watching, said resources and more, and then the KNI becomes that conduit and more, and it may actually line up rather elegantly. And then we can also start looking at future items on the multi-network roadmap, because if you in the sync pod, we actually can knock out updates rather easily. However, it required the pod network resource. So there's some good intersections. It probably makes sense for our next shindig, or even I can't remember the date for KNI sync, to kind of figure out, yeah, where we can help out, reduce the scope, propel multi-network forward, get KNI in, then, how we can chip away at, the future roadmap, like advanced functionality around services, or, your opinionated approaches of networking, network policy, and more, because I think it's gonna, obviously we need to be in some sort of alignment here.
Yeah, sounds good. All right, folks, I think we are way over the time. Yeah, let's call it a day. And should we continue this next week? Is there some more you want to say more, Michael, on this?
I think it's just intersections, nothing too crazy.
Okay, let's do that. Yeah. All right, folks. Thanks, Michael, for your presentation and discussion. This is really this is helpful for me, because I caught up on what you did for the last month or so. Thanks for that.
Anytime.
All right. Thanks, everyone. See you next week.
Thanks.